By 1944, the United States was producing more military equipment every 3 months than Germany had manufactured in the entire first 2 years of the war. The question historians have never quite answered is how a country that had ranked 16th in global military spending in 1939 built that kind of machine so quickly. And this is the part nobody talks about. In the autumn of 1945, a team of economists and military analysts working under the umbrella of the United States Strategic Bombing Survey sat down with the production records of the American war economy and began running the numbers. What they found took them weeks to fully process. The United States had, between January 1942 and August 1945, produced roughly 297,000 military aircraft. It had produced 86,000 tanks and self-propelled guns. It had produced 2.4 million military trucks, 6,500 naval vessels, and enough artillery ammunition to fill freight trains stretching from New York to Los Angeles and back again. The analysts were not naive men. Several of them had spent time inside the German and Japanese war economies. They understood the mechanics of industrial mobilization, and still the scale of what they were looking at exceeded the categories they had brought to the work. The question they kept returning to was not whether those numbers were real. They were real. The question was how a country that had entered 1940 with an army ranked 18th in the world, behind Romania, behind Portugal, had crossed the gap between that condition and this one in fewer than 5 years. The answer, when it finally emerged from the documents, turned out to involve a set of decisions made years before the war began by a group of people whose names are almost entirely absent from the standard histories of the conflict. It also turned out to involve a specific architectural and engineering tradition that had been quietly building the physical infrastructure of mass production across the United States for 3 decades before the first American soldier entered combat. To understand how the American war economy actually worked, it is necessary to go back to a moment that seems at first entirely unconnected to war. In the spring of 1913, a young Danish immigrant named William Knudsen was brought to Detroit by Henry Ford to oversee the installation of something Ford's engineers had been developing for the previous 2 years. The moving assembly line had existed in partial forms before Ford adopted it. Meatpacking plants in Chicago had used overhead conveyors to move carcasses past stationary workers since the 1860s. What Ford wanted to do was apply a version of that principle to the manufacture of automobiles. What Knudsen understood, and what distinguished him from almost every other production manager in American industry, was that the assembly line was not a machine. It was a system. And the difference between a machine and a system is that a machine can be copied, while a system has to be understood from the inside before it can be reproduced anywhere. Knudsen spent the years between 1913 and 1921 building Ford's branch assembly network across 28 cities, coordinating the flow of parts and subassemblies across a geography that had no precedent in manufacturing history. When he left Ford in 1921 and moved to General Motors, he brought that understanding with him. At Chevrolet, which was then a struggling and barely profitable brand, he redesigned the production process from the ground up, and within 3 years had turned it into the highest-selling automobile line in the United States. By 1937, when he became president of General Motors itself, the corporation he ran was producing more vehicles per year than any other manufacturer anywhere in the world. The salary he was paid, $300,000 annually, was not a coincidence. It was the market's precise estimate of what that specific knowledge was worth. When Franklin Roosevelt called Knudsen to Washington in the summer of 1940, the war in Europe had already produced its most dramatic early result. France had surrendered. The German army occupied Paris. The British Expeditionary Force had been evacuated from Dunkirk, leaving behind virtually all of its heavy equipment. Roosevelt needed someone who could look at the American industrial base and tell him, honestly and without political calculation, what it was actually capable of producing and in what time. Knudsen arrived in Washington, accepted a federal salary of $1 per year, and began traveling. He did not stay in Washington long enough for it to become comfortable. He went to factories in Ohio and Michigan and Connecticut and California. He walked through production bays and loo, ked at tooling arrangements and asked questions, and when the answers told him something was wrong, he would sometimes pick up a piece of chalk and draw the correction on the factory floor before he shook hands with the plant manager and moved on to the next plant. The first major test of what Knudsen could do came from a phone call he made in June 1940 to a man named Kaufman Thuma Keller, the chief executive of the Chrysler Corporation. Knudsen asked Keller whether Chrysler could manufacture tanks. Keller's response has been preserved in Arthur Herman's account of the period. He told Knudsen that he had never seen a tank and could not answer the question until he had looked at one. The two men drove to the Rock Island Arsenal in Illinois, where Keller spent several hours walking around a medium tank M2A1 and watching his chief engineer put it through its basic movements. At the end of that examination, Keller told Knudsen that Chrysler would build tanks. He specified one condition. They would not build them the way the Arsenal built them. They would build them on an assembly line. The contract between the United States government and Chrysler was signed within weeks. The site chosen for the new plant was a flat, undeveloped farm field outside the village of Warren, Michigan, and the man hired to design the building was Albert Kahn. Now, here is the part the history books rarely tell completely. Albert Kahn had been born in 1869 in the Rhineland region of what was then the German Empire, the son of a rabbi in a small town with no architectural tradition worth mentioning. His family had immigrated to Detroit when he was around 11 years old, and because they had no money for formal education, he was apprenticed at 15 to a Detroit architectural firm. He taught himself the technical side of his profession largely from books and from the observation of buildings that were going up around him. By 1903, he had opened his own firm. By 1909, Henry Ford had hired him to design the Highland Park plant, which would become the first facility in the world to operate a complete moving assembly line under one roof. Kahn, Unders, told something about industrial buildings that almost no other architect of his generation had worked out. The building was not a container. It was a component of the production process itself. The placement of columns, the width of bays, the orientation of skylights, the gradient of floors, all of it affected what could be built inside the building and how quickly. He designed around the process, not around the aesthetics. By the mid-1930s, Albert Kahn Associates was responsible for nearly a fifth of all architect-designed industrial construction in the United States. The Ford River Rouge complex, which Kahn had designed, was the largest integrated manufacturing facility anywhere in the world. But the connection that made Kahn's role in the Second World War genuinely strange was one that had nothing to do with Ford or Chrysler or any American client. In 1929, the Soviet government, then at the beginning of Stalin's first five-year plan, concluded that the fastest way to industrialize the Soviet Union was to hire the man who had built American mass production infrastructure and have him build Soviet mass production infrastructure. They came to Detroit. They asked Kahn to design a tractor plant at Stalingrad. He agreed, delivered the plans in record time, and was immediately asked to design another plant, and then another. By the time the Soviet contract ended in 1932, Kahn's firm had designed more than 500 industrial facilities across the Soviet Union, and had trained more than 4,000 Soviet engineers in American production methods. The Stalingrad tractor plant, the first facility Kahn designed for the Soviet government, was manufacturing 50,000 civilian tractors annually by the late 1930s. When Adolf Hitler ordered the invasion of the Soviet Union in June 1941, the plant had already been retooled to produce a medium tank designated the T-34. Within months, it was the single largest producer of T-34s in the entire Soviet war economy. In the autumn of 1942, when German troops from the Sixth Army fought their way through the ruined outer districts of Stalingrad and into the factory district itself, the workers at the tractor plant were assembling tanks on the production floor and driving them directly out of the building into combat with the German infantry units attacking from the opposite direction. Albert Kahn had died in December 1942, while the battle was still being decided. He did not see the Sixth Army surrender. He had built the factory that built the tanks that destroyed the army of the country where he had been born, and he had done it more than a decade before the war began, as a straightforward business transaction. The Detroit Arsenal tank plant, the facility Kahn designed for Chrysler at Warren, followed a structural logic derived from the same principles Kahn had refined through the Ford and Soviet commissions. The exterior walls were poured to a thickness of 3 feet in case of aerial bombardment, a precaution that was essentially theoretical given Detroit's distance from any realistic enemy aircraft range, but which reflected Kahn's habit of designing for conditions beyond the expected. Construction began in September 1940. The first tank, an M3 Lee medium, rolled off the assembly line on the 24th of April 1941, at a point when significant portions of the surrounding building were still under construction. By the end of 1941, the arsenal was producing more tanks per month than the entire German armaments industry had managed in the corresponding period. That was the opening figure. It was not the ceiling. The production expansion that followed the Japanese attack on Pearl Harbor in December 1941 went beyond what the Army's own planning documents had projected. This was not because the planners had been careless. It was because the planning models were built on the assumption that industrial capacity was roughly fixed in the short term and could only be grown incrementally. What actually happened was that the entire civilian manufacturing sector of the American economy converted to military production, with a speed that the planning models did not have a framework to accommodate. General Motors stopped making automobiles and began making aircraft engines, tanks, trucks, and artillery components. Ford converted its Willow Run facility, which Kahn had also designed, to the production of B-24 Lee for Raider bombers. The Willow Run plant covered an area of over 1 million square feet under a single roof. At peak production, it was completing 1 B-24 every 63 minutes. The aircraft figures, taken as a whole, represent perhaps the starkest single illustration of what American industrial capacity meant in practice. In 1939, the United States produced approximately 2,100 military aircraft. In 1940, the number rose to just under 6,100. By 1942, it had reached 47,800. By 1944, at the production peak, the United States completed 96,318 military aircraft in a single calendar year. Germany, in its best production year, 1944, despite every effort Speer and his reorganized armaments ministry could make, produced approximately 39,800 aircraft. The ratio was close to 2.5 to 1, in a year when Allied bombing was striking German factories continuously. The Japanese comparison was more extreme. Japan produced approximately 28,000 aircraft in 1944. The United States produced more than 3 times that number while simultaneously supplying aircraft to Britain, the Soviet Union, Australia, and a dozen other Allied nations under the Lend-Lease program. The Lend-Lease figures are, in their own way, as striking as the direct American production numbers. Between March 1941, when the program was authorized by Congress, and August 1945, the United States transferred to its allies approximately $50.1 billion in goods and materials. That figure included 14,795 aircraft sent to the Soviet Union, along with nearly 400,000 trucks, 13,000 combat vehicles, and enough food to provide roughly half the caloric intake of the entire Red Army for the duration of the war. Soviet marshals who were asked about this after the war tended to deflect the question on ideological grounds. But Georgy Zhukov, in private conversations that were recorded by Soviet intelligence officers and only became public decades later, was more direct. He said that without America and trucks, the Red Army could not have moved. Without American food, it could not have fought. The industrial output that made Lend-Lease possible was the same output that equipped American forces across 2 oceans simultaneously. The United States did not choose between supplying itself and supplying its allies. It produced enough to do both. What made this possible was not, in the end, any single decision or any single person, though Knudsen's contribution to the organizational structure of American war production was more significant than any other individual's. What made it possible was the existence of a manufacturing infrastructure that had been built over the preceding 3 decades through the accumulation of specific knowledge. Knowledge about how to arrange production lines, how to coordinate the flow of components across large distances, how to train workers in precise and repeatable operations, and how to design buildings that made all of the above more efficient. That infrastructure had been built by men who, in most cases, were not thinking about war. Ford and Knudsen and Kahn had been thinking about automobiles and tractors and the economics of mass production. The war gave that infrastructure a new set of problems. The infrastructure turned out to be capable of solving them at a scale that no one, including the men who had built it, had explicitly planned for. The German failure to anticipate this was not a failure of intelligence in the narrow sense. German military intelligence had access to American production statistics. Albert Speer had read the figures on Sherman tank production and American aircraft output. The failure was a failure of imagination of a specific and understandable kind. The German armaments industry was built on a craft tradition. Highly skilled workers producing complex components to tight tolerances, a tradition that produced excellent weapons in relatively small numbers. The American system was built on the opposite principle, that a process sufficiently well designed could be operated by workers with minimal prior training and still produce acceptable weapons in effectively unlimited numbers. Speer understood the first, tradition, from the inside. He understood the second only as a set of numbers on a page, and numbers on a page are not the same thing as understanding. The Sherman tank is the clearest case. By almost every technical measure that German tank crews applied, armor thickness, gun caliber, mechanical reliability in extreme conditions, the Sherman was inferior to the Panther and significantly inferior to the Tiger. German tank commanders who fought against Shermans at Normandy and across France noted this in their after-action reports with considerable consistency. The Sherman caught fire more readily than German tanks. Its gun required more hits to penetrate German armor at typical combat ranges. The German crews who survived the early engagements in Normandy understood that they were operating technically superior vehicles. What they could not compensate for was the rate at which destroyed Shermans were replaced. A Panther knocked out in TGE morning might not be replaced for weeks, if it was replaced at all. A Sherman knocked out in the morning was likely to be replaced before nightfall, because the supply lines behind the American forces carried reserves in quantities the German logistics system could not match and had not been designed to match. By the end of 1944, the productive margin had grown wide enough that American commanders were making decisions that would have been inconceivable for any other combatant power on any side of the conflict. Dwight Eisenhower's headquarters was issuing operational plans that assumed continuous and essentially unlimited resupply of vehicles, ammunition, and fuel across a front stretching from the English Channel to the Swiss border. The assumption was not always correct in the short term. The supply crisis in the autumn of 1944 created genuine operational constraints. But the underlying premise that American industry could produce faster than American forces could consume was correct, and it shaped every strategic decision made at the senior command level from 1943 onward. The German General Staff had no equivalent premise to work from.